Good day everyone, my name is Drill Manalang and today I will be teaching you guys about cryptography. So today we're going to work on problems that involve encryption and decryption. Now of course I'm assuming that you guys have already read and watched the previous module about coding theory and that you've already read the modules about this one, about cryptography itself. So we're going to focus on Caesar cipher and Vigenère cipher. We're, we're only going to focus on two crypto systems because as much as I want to discuss a lot of types, affine cipher, substitution cipher, and other rare types of ciphers, it's going to take too much time. And quite frankly, in my opinion, if you've already understood these two ciphers over here, these two crypto systems, I feel like you can already understand how crypto systems work. So let's get started with the first one, decrypt. Okay, decrypt, not encrypt. Decrypt the following using Caesar cipher. Okay, so first of all, let's recall what is a shift cipher. A shift cipher is a crypto system that has a key, which is denoted by K. And this key is any value not more than 20. Wait. I think the key can be more than 26, but it's going to be modulo 26, so it doesn't really matter. But anyway, basically K is a value, a numerical value, and that numerical value means that it shifts the alphabet to the left that many times. So if K is equal to 2, A is going to be shifted to the left 2 times. And Caesar cipher is K is equal to 3, which means that okay, I'm sorry, I'm quite sick. But anyway, which means that A is going to be shifted 3 times to the left. And let me just visualize it so that you guys can understand what I'm trying to say. Okay, let's just make 2 rows over here. So K is equal to 3, A is going to be 1, 2, 3. B is going to be 1, 2, 3. Now D is going to be 1, 2, 3. Therefore, this D is going to go here. So A is to D. Therefore, B is to E, C is to F, and so on and so forth. And that's basically what I'm trying to say. That's basically the principle of shift cipher and Caesar cipher. Now, okay, this is the given. What we have here is a very, very, very convenient wheel. Okay, this is going to save us a lot of time because all we have to do is to wait, let me just find the pen. Okay, all we have to do is to look at the values. Okay, as mentioned in the problem a while ago, we have to decrypt this, which means that this is already a ciphertext. Okay, this wheel over here, okay, this purple wheel over here, these are the cipher, and this green over here, this is the plain text. So we're going to convert the purple to the green. So let's start. So M becomes J, X, the purple X becomes the green U. O, where's O? O is here. The purple O becomes the green L. The purple L becomes the green I. The purple D becomes A, which is what I've explained earlier. Okay, D becomes A because it's been shifted. Initially it was here, and then 3 places, it's now here. So yeah, and Q, the purple Q is going to turn into N. And that's it. That's the plain text. Okay, we've already decrypted it. But let's imagine this. Okay, let's imagine we haven't seen this. Okay, this didn't exist. Okay, it's not there. Okay, it's not there. And the problem said you need to encrypt Julian using Caesar's cipher. So now the scenario now here is that these are green letters and we're going to convert it into purple ones. So J, the green J, where's the green J? J is going to be M. The green U is somewhere here and it's going to be X. The green L is O. The green I is L. The green A is D. And the green N is, where's the green N? Q. And as you can see, it's the same. It's exactly the same. And yeah, that's it. It's really simple. Okay, it's not that hard. Now moving on, this one is the Vigenère cipher. This is slightly more complex than this shift cipher, but honestly, it's not really that hard. Okay, it's just kind of more tedious. Okay, but encrypt and decrypt. Okay, so first we're going to encrypt this, okay, because this is the plain text. And then once we already know the ciphertext, we're going to convert it back again to the plain text. Okay. Now this is important. In the Vigenère cipher, there is a keyword. Okay, this is important. GG is important. So now, first of all, we have a table here. This table provides a numerical value for each and every letter. Okay, in other sources, in other lessons, okay, if I recall, Miss Alana discussed, in Miss Alana's discussion, A is equal to 0, if I recall correctly. But in this one, what I found in Google is A is equal to 1, but it still works the same. It's still the same thing. It's going to give us the same results. So yeah. But if A is equal to 0, that means the final letter is equal to 25. But that's it. Okay, so the key is GG. So what we have to do here is, first let's find G here. It's 7. And 7 again. So now there. Now we have to find the numerical values of these letters. So J is 10. U U is 21. L is 12. I is 9. A is 1, of course. N is 14. Now, excuse me. The key stream refers to GG. And GG, you can basically just repeat it. Okay, it's basically repeated. If this was, for example, U. For example lang then let's convert U. It's 25. O is 15. U is 21, I believe. Okay, yeah. So, if, example, yung key is U, and ilalagay natin dito, 25, 15, 21, tapos 25, 15, 21. It's basically just repeating, okay? So, yeah. But the main reason why I chose GG is so that it's just a repeating value. We don't have to stress out. It's just an easy problem. We don't have to do so much effort. So, what we're going to do here is simple. 10 plus 7 is 17. 21 plus 7 is 28. However, 28 is more than 26. Okay, 28 is not in this table. So what we're going to do is we're going to subtract 26 to 28. So that 28 minus 26 is 2. And 2 is in the table, which is B. Okay, so 2. 17 plus 7 is 19. 9 plus 7 is 16. 7 plus 1, 8, 14, 21. There we go. Now, all we have to do is to find the reverse. Basically, now we have numbers. We need letters. 17 is Q. 2 is B. 19 S. Okay, where was I? 19S, 16 P, 8H, and 21 U. And as you can see, these these letters are the ciphertext QBSPHU. And now we're going to do the inverse. Okay, let's imagine we don't know this. Okay, let's imagine there's no such thing as that, but the only thing we have is QBSPHU. Okay, we don't know the plain text, but we know this. Okay, this is always given, because if it's not given, then it's impossible to solve this basically. So let's just let's just take the wait. Let's just first of all let's put this 7 7, and then let's just take the numerical values. Q is 17, B is 2, S is 19, P is, where's P, 16, H is 8, and U is 21. In a key stream, once again, GG, GG, GG. Now, the next one, if earlier it was addition, this one it's subtraction. So 17 minus 7 is 10. 2 minus 7 is equals to -5, right? And -5 is not in this table. Wait, I'm sorry for this. I butchered that 5. Okay, there, -5. -5 is anywhere here. So what we're going to do is we're going to add 26. And therefore it's going to be 21. Right? Okay, it's going to be 21. And now, where was I again? 19 minus 7 is 12. 16 minus 7 is 9. 8 minus 7 is 1. 21 is 14. There we go. So now 10. Where is 10 here? 10 is J. 21 is U. 12 is L. 9 is I. 1 is A. And last but not the least, 14 is N. And now that means our process is correct because we arrived at the same plain text. Okay, Julian. You know your process is correct if you arrive at the same starting point. So that's pretty much it. There's nothing more to it. As I've said, it's not that hard. So yeah. Goodbye, and thank you for reading the website contents. Thank you for watching the earlier videos, and that's it. Thank you.